Welcome, welcome. So good to see you. Make yourself comfortable because today we're exploring the fascinating advancements in artificial intelligence, specifically focusing on enhancing mathematical reasoning in language models. We're diving into the insightful research paper titled Improve Mathematical Reasoning in Language Models by Automated Process Supervision by the brilliant minds at Google DeepMind and Google. Now, as many of you might know, even the most advanced large language models, or LLMs, encounter significant challenges when it comes to complex multi-step reasoning tasks. Whether it's solving intricate mathematical problems or generating sophisticated code, these models often stumble, especially when the reasoning process involves multiple steps or hops. Traditionally, one of the common strategies to bolster the reasoning capabilities of LLMs has been the use of outcome-reward models, or ORMs. These models evaluate the final outcome of the reasoning process to provide feedback. While this approach does offer some improvements, it falls short when dealing with lengthy or intricate reasoning chains. That's because ORMs don't adequately address the intermediate steps, leaving a gap in the model's ability to fine-tune its reasoning process effectively. Enter process reward models, or PRMs, a more granular approach that assigns rewards at each step of the reasoning process. PRMs offer a significant advantage by providing detailed feedback on each intermediate reasoning step, effectively pinpointing where things might be going astray. This step-by-step feedback is akin to having a teacher guide a student through each part of a complex problem, ensuring a deeper and more accurate understanding. However, there's a catch. Developing PRMs has been a laborious task, primarily relying on expensive human annotations or computationally intensive Monte Carlo estimations. These methods, while effective, are not easily scalable, limiting their widespread application. This is where the research from Google DeepMind and Google shines. They've introduced a novel algorithm called OmegaPRM, a divide-and-conquer style Monte Carlo Tree Search, or MCTS. Inspired by the strategies used in AlphaGo Zero, OmegaPRM revolutionizes the way process supervision data is collected. Instead of the traditional time-consuming methods, OmegaPRM swiftly identifies the first error in the chain of thought using a binary search approach. This not only enhances efficiency, but also ensures the quality of the data collected. The results are nothing short of impressive. By leveraging OmegaPRM, the researchers were able to amass over 1.5 million high-quality process supervision annotations without any human intervention. This monumental feat enabled them to train robust process reward models that significantly boost the mathematical reasoning performance of existing language models. Let's talk numbers. The instruction-tuned Gemini Pro model saw its success rate climb from 51% to an impressive 69.4% on the MATH500 benchmark. On the GSM8K dataset, the improvement was even more striking, jumping from 86.4% to 93.6%. Similarly, the Gemma 2 27B model experienced a leap from 42.3% to 58.2% on the MATH500, and an astounding rise from 74.0% to 92.2% on GSM8K. These enhancements were achieved entirely through automated process supervision, sidestepping the need for costly human annotations and making the process both financially and computationally efficient. The implications of this research are profound. By automating the supervision process, OmegaPRM paves the way for more scalable and cost-effective enhancements to language models. This means that as we continue to develop increasingly sophisticated AI, we can do so without being bogged down by the prohibitive costs and time associated with manual data annotation. Moreover, this approach isn't limited to mathematical reasoning. The principles behind OmegaPRM can be extended to other complex reasoning tasks, potentially revolutionizing how we train and refine AI models across various domains. Imagine more accurate and reliable AI assistants capable of handling intricate tasks with the precision and consistency that was previously unattainable. In conclusion, the research presented by Google DeepMind and Google marks a significant milestone in the journey towards more intelligent and capable language models. By introducing OmegaPRM, they've not only addressed a critical bottleneck in AI development, but also set the stage for future innovations that promise to make AI more reliable, efficient, and accessible. Thank you for joining me today in exploring these exciting developments. Stay curious, and until next time, keep pondering the possibilities of artificial intelligence.